Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to Lost in Science. It is, well, it's my favourite science program on the radio or the podcast. Whoever you listen to this, fantastic thing. How about you, Kat and Claire?
Hello, I would say this is pretty up there.
You don't want to go too far.
I mean, we are
ourselves.
We are rational scientists, so, you have to leave a little bit of room for, potentially there might be another one that comes along.
That's true. We need you need the data. You can't prove. Can you prove a negative, or you can't prove? I can't remember which one you can't prove.
I think it is difficult to prove a negative.
But then don't you see the counterexample? Like if you want to prove something is not true, you just have to find a counterexample to the thing that you thought was. I don't know.
In summary, we're great.
Yeah, in summary, we're great. I think that's what we're trying to say. Yeah. Philosophy is science, though. Maybe not the topic of today's conversation. What is the topic of today's conversation? Well, we've got Kat Triona, who I believe has some interesting research to share with us. Take it away.
Yeah, I'm going to be talking about one of the most distant, brightest objects that we can see, which are quasars.
Lovely. So, Claire, what are you bringing to the science table?
Well, both Kat and I are going big sort of solar system cosmology, astrobiology for you all today.
The science is going to be out of this world.
That's right. If you don't know what happened 4.5 billion years ago, researchers can suggest to you, there is a theory that is in fact when a protoplanet around the size of Mars collided into early Earth. And there was such a huge collision that it created the moon.
That is quite a claim. And, like you said, for those who might have not noticed that, they probably noticed the moon and thought, where did that come from?
That's right. I know. Yeah, that's one of the big questions. Where did the moon come from? And 4.5 billion years ago is when we need to look back to answer that question. So I'm going to talk about some new research that adds some evidence to this theory, and it's made even more special because the name of the Mars-like planet and the name of my daughter are the same. So
that's an incredible coincidence.
It is an incredible coincidence that we have the same name of some world changes in our midst, both the little ones and the big ones.
Excellent. Can't wait to hear that. On with the show.
Telling you a little bit about quasars.
Hang on, Kat. I have to put my hand up here. Mm-hmm. What is a quasar? Is it a laser? Is it a quasi laser? What is a quasar?
Well, if I was playing charades, I might do sounds like laser, but I think, perhaps Chris might weigh in here, but I think one of the only things that lasers and quasars have in common, besides the sound, is the fact that they have something to do with light.
Ah, okay.
Sounds about right, yeah.
So quasars are among the most luminous objects in the known universe, and they typically emit thousands of times more light than the entire Milky Way galaxy. So they have a lot of light. I would say probably more light than a laser.
So hang on, are they a star then? Are they like what celestial body are we even talking about here?
Well,
it's
Chris,
its own thing.
It is. It's not a star, but just a little bonus side note, fun fact: the word quasar is a contraction of quasi-stellar radio source. Because when they were first identified during the 1950s as kind of sources of radio wave emissions, but they didn't know where it was coming from. And then when people saw photographic images in kind of the visible light spectrum, they were like, oh yeah, it kind of resembles faint star-like points of light. So I guess they're kind of like stars. So
Quasi?
Quasi-stellar, quasi-star.
Quasi-stellar. That is a great tidbit. I hope I remember that for next Lost in Science trivia night.
And everyone should remember that. It's a great trivia fact. But yeah, they are their own thing. They are the cause of galaxies that are being lit up by the power of supermassive black holes.
Yeah, I think the key thing to remember here is that they're a long, long way away, aren't they?
Well, they are far away, but they can be different distances. which I'll get to. They are far. We don't have any very close to us. But essentially what's happening is the supermassive black hole grows rapidly because it's gorging on huge amounts of gas, which spirals as an accretion disk around the black hole, and that becomes very hot and very bright. And so what people are actually seeing is gas and dust falling into the supermassive black hole, and that emits light. I mentioned radio already, and I mentioned visible light. So it actually emits light across the entire electromagnetic spectrum. So all the light. It makes all the light.
Wow, yeah.
They make these vast amount of light. And I do want to talk about distance. So, Chris, you brought up distance. And just as a little reminder, when we look at astronomical or celestial objects like stars and quasars, we observe them from here on Earth, and we're looking at them as they were seen from when the light left them. So if, for example, you take our closest star to us that's outside of our solar system, and that's 4.5 light years away, when we see the light from that star, we're looking at it 4.5 years ago. And so the study of quasars can actually provide quite fascinating insights into the evolution of the universe, because they are far away, and we've captured images of quasars up to billions of light years away. So when Chris said that they're far away, like, there can be billions of light years away. So looking at them is essentially to look back in time. And
right. So it's incredibly helpful that they're really, really bright, because the brighter they are, the more the light travels to us, then the longer ago it was, and the more we can understand.
Well, yeah, the longer ago it was, the more we can sort of learn about a time when the universe was young, because that light's coming from all this time ago. And quasar activity was more common in the past. So, yeah, Chris, you're right. Like, a lot of them are very far away, and they sort of...
They call them the good old days of the universe.
The good old days peaking around 10 billion years ago. And the nearest quasars to Earth are still several hundred million light years away, meaning that they're observed now as they were perhaps 600 million years ago or so. So, I think the closest ones are that far away.
That's pretty deep. That's pretty recent, though, when you think about it.
Like,
that's when there was like life on Earth, and
yeah. That's why I was actually surprised when I saw that, because I knew them as something that were quite far, quite distant. But when I saw that some of them are actually quite close, it's like, not that far away. As you point out, there was life on Earth at that time, and the fact that we can't see quasars closer to us here on Earth doesn't mean that there were never quasars in our kind of little patch or our region of the universe, but it instead means that if they existed around here, it was when the universe was younger. So by now, the light's all gone. We can't see them anymore. But in terms of the furthest quasar away, the record for the most distant known quasar continues to change, but all the candidates are massive cosmic monsters more than 13 billion light years away. And if you think about the Big Bang, that was 13.8 billion years ago. And so this is quite long ago.
Quite long ago. Wow.
Yeah. I think the record is from in 2021 when a quasar with a supermassive black hole that's more than 1.6 billion times more massive than the sun was observed, and its light is from only 670 million years after the Big Bang. So it's quite old. It's very old.
It's very old.
Imagine that many candles on your birthday cake. But what I want to share with you today is kind of a record-breaking quasar. So using the European Southern Observatory's Very Large Telescope, very aptly named because it's a pretty large telescope, astronomers characterized a bright quasar, finding it to not only be the brightest quasar, so brightest thing of its kind, but also perhaps the most luminous object ever observed.
Whoa.
So much light coming from it.
Wow.
And as they do, they named it something complicated like J0529-4351.
Just rolls off the tongue, doesn't it?
Yeah, it really does. Lovely name. It needs a bit of a nickname. And that particular quasar, I'm not going to say the name again, is so far away from Earth that its light took over 12 billion years to reach us. So it's also quite old, but it's not the oldest. And as a general sort of rule, the brightest quasars indicate the fastest growing supermassive black holes. So the black hole in this one has the mass of 17 billion suns, and it's growing in mass by the equivalent of one sun per day, making it the fastest growing black hole to date. So it's just like gobbling up the mass of an entire sun every day. That's a lot.
That is a lot.
It's pretty hungry.
It's just, all I can think of is this Pac-Man black hole just gobbling
that's what comes
up.
to my mind too. But the one that I talked about before being the furthest, it's eating the equivalent of 25 suns every year. So yeah, that sort of comparison of this one having one sun per day, that's pretty fast. So funnily enough, this amazing quasar that breaks the record for being really bright, breaks the record for being like having a black hole that's gobbling up matter faster than we've ever seen. It was hiding in plain sight for so long, or rather, I guess, staring astronomers in the face. So it actually showed up in images from the European Southern Observatory's Schmidt Southern Sky Survey, which dates back to 1980. But it wasn't recognized as a quasar until decades later. And now astronomers at ANU have realized just how incredible it was. So they were looking at the data and they realized it was a quasar, but it required a little bit more work to actually determine that it is so bright and so record-breaking. So finding quasars requires precise observational data from large areas of sky, and the resulting data sets are so large that researchers often use machine learning models to analyze all of that and to tell quasars apart from other celestial objects like stars in particular.
So AI again.
Yes, AI. Good old AI. But the problem with AI is that it's trained on existing data, which limits the potential candidates to objects that are similar to what is already known, like what we already know and what the computers and the AI can know. But if a new quasar like this one is brighter than anything we've seen before, the program just rejects it and classifies it as a star that's actually not too far away from Earth. So it took this sort of automated analysis passing over it, and then the researchers going, hang on a second. So the ANU researchers identified it as a quasar, and then they actually paired it with some observations from the Very Large Telescope in the Chilean Atacama Desert, and doing so, pairing the data together, they could establish, okay, this is indeed a quasar, and it's really bright, brighter than we've ever known. So there we go. That's a lovely combination of humans plus AI finding this great thing. So yeah, we've got beautiful, bright objects in the sky. Are they stars? Are they quasars?
Don't ask the computers.
Yeah.
Science, the final frontier. These are the voyages of Lost in Science, our ongoing mission to explain strange new words, to seek out new science and new explanations, to boldly go where no radio has gone before.
So there are some big questions about how the Earth came to be. And one question that you might have thought about when you looked up at the night sky, saw the big glowing orb that we all look at up there. I'm of course talking about the moon. Maybe you've wondered, where did our loon, where did our moon come from? Like, was it always there?
Yeah,
was
I
it
mean,
a celestial friend or a rabbit or a man, was it?
surely it's just been around forever. It's been as long as I remember.
I mean, right? Oh gosh. Well, in living human memory, it's always been there. It's always been accompanying, changing the tides, lighting up the night. But there is new research, and I'm busting to tell you about it before the end of the year, and that gives us a better understanding of where the moon comes from. And the reason I'm so keen to talk about it is that the answer to the question, where did the moon come from, as I said in the intro, is also the name of my tiny little daughter. And that answer is Thea. Some people might pronounce it Thea, but I pronounce it Thea. So
that's right.
So that's right. So I'm going to say Thea in this story.
So Claire, your daughter, I understand, is still quite young. How did she create the moon?
Well, it's just the name, Chris.
Oh, okay.
She didn't create the moon.
Or did she?
She's world changing, but mostly for her mum and dad at this stage. Let me just say, but also no expectations, Thea. Okay, but let me go back a little bit, because the original Thea is the name of a Greek titan. So the original Thea, she was the mother of the moon, who's the goddess Selene.
Appropriate name.
And she's also the mother of the sun god Helios. So my small daughter, Thea, she was born on the vernal equinox, when the sun and the moon are equal. So we thought Thea was a perfect name for her. But Thea is also the perfect name for another much larger object. And that happens to be an ancient protoplanet around the size of Mars. And scientists called this supposed ancient protoplanet Thea because it collided with, they hypothesized that it collided with the Earth 4.5 billion years ago, smashing everything into pieces and creating a whole lot of havoc, which then created the Earth as we know it and love it and call home, and more importantly, creating a satellite that wasn't there before, the moon. So a great name, huh? Thea.
I mean, we have all our movies, our Deep Impacts, our Armageddons and these sort of things where, like, asteroids hit the Earth with devastating results. We had the dinosaurs. We know that's, what happened to them. But that's nothing compared to, like, a planetoid, something the size of Mars. Yet no wonder it created such big changes. But what devastation did it do to the Earth? Like, what did it do?
I mean, it just changed everything. The Earth was only 85% of its current size before Thea impacted. And then it created the moon, and then just made Earth a lot bigger as well, and has sort of just changed everything. And I'll talk a little bit about exactly what it changed in the rest of the story. But yeah, it's been a theory. It's also known as the giant impact theory, the big splash. which I like. The big
The splash implies wet. To me, anyway.
It does. That's right. Maybe there was water 4.5 billion years ago. Something they're not telling us.
Or was the rock all molten when it happened?
Well, the rock. Oh yeah, maybe the big splash.
Yeah.
Because it was a pretty new Earth.
Yeah.
So maybe that's the splash, molten rock. Oh gosh, that sounds like the world's worst puddle. It's also called the Theia impact. And yes, as the name suggests, the moon was formed from these remnant ejections of this collision between the early Earth and Theia. And interestingly, this theory, it goes back quite a way. So it was originally suggested in 1898 by a scientist called George Darwin, and he hypothesized that the Earth and the moon came from one single body, but didn't quite talk about sort of that it was this protoplanet Theia. And then in 1946, Reginald Daly hypothesized that the moon was caused by an impact with the Earth. And yes, it would have been a incredibly huge impact. So it melted most of Earth and Theia. So it was such force that both planets melted and reformed. Like I said before, Earth a lot bulkier, and meanwhile, huge amounts of dust and rock were blasted into orbit. So for a little while there, Earth, I guess, would have had some rings around it.
Oh, wow.
And then they came together and coalesced to create the moon. So this giant impact hypothesis, it sounds pretty amazing, and by all accounts it explains a lot about what we know about the Earth and the moon. But like all good theories, it has to be supported, and we need evidence for this collision, this hypothesized collision. And that brings me to this research that I want to talk about that was published in November. I've been busting to tell you all. It involved an international team of researchers and a paper published in Nature titled Moon Forming Impactor as a Source of Earth's Basal Mantle Anomalies. Okay, so let me break that down. The moon forming impactor here is, of course, our dear Theia, our Mars-sized planet, and Earth's basal mantle anomalies, try saying that 10 times fast, are in fact these, I guess, continent-sized blobs that are buried deep, 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 deep inside the Earth's mantle beneath Africa and the Pacific Ocean. And these blobs that geoscientists have discovered are different to the rest of our Earth. They're very, very different.
Yeah, so what's the mantle again? Can you just remind us what the mantle is?
Isn't it the just above the core of the Earth?
Yeah, so there's like the core, and then there's the mantle, and then there's the crust.
There we go.
Oh, okay.
Is it?
Thank you.
It's
So-
sort of like the sandwich filling.
If the Earth was a Ferrero Rocher, would the mantle be like the hazelnutty cream thing, and the
Yes.
core is like the nut in the middle, and the crust is
And
the
then the
chocolate?
crust is the foil.
Yes.
Yeah.
Yes. The mantle.
Yeah, that
the
chocolate.
mantle is the. I've eaten a lot of Ferrero Rochers recently. It's the Nutella
Okay, that's what it is. Yeah,
in the yep, just around the hazelnut. Yep.
but it's bigger
Exactly.
because it's most of the Earth is the mantle, like the biggest part, isn't it? Like the thickest part.
Yes,
Yep.
it is the thickest part. Yep. And so there's these blobs that have been discovered in the mantle, in our Nutella mantle, then technically known as large, low-velocity provinces. Just these names. They were originally discovered by seismologists, but exactly where they came from, what was going on with them, it's never been clear, and it's certainly never been linked to Theia, a potential collision with a Theia-like, Mars-like planet 4.5 billion years ago. That is until the researchers from the California Institute of Technology and Shanghai Astronomical Observatory, they used computer simulations to look at the giant impact between Theia and Earth and convection currents inside Earth, inside the mantle. And according to these simulations, the collision between Earth and Theia would have melted the upper half of the Earth's mantle. So that allowed a big chunk of Theia, the planet, maybe even around 10% of this planet, to get into the Earth's mantle, penetrate its way in, and gradually sort of start sinking down.
Oh, wow.
So then over the next 4.5 billion years, with convection within the Earth, sort of starts moving these blobs of what used to be part of Theia through the mantle, and we start to see these blobs take the form that we see today. Now, these blobs are 2,500 kilometres buried deep down in the Earth, but they are slightly denser than the surrounding mantle rock. So they're very close to the boundary with the Earth's core. So they have been moving slowly through the mantle towards the core. Now, the next steps will be to verify these computer simulations with some actual moon rock. They're hopefully, sometime in the future when space missions get back to the moon, hoping to get some rocks from the mantle of the moon back to Earth so we can do some chemical signature work of the blobs on Earth and the mantle on the moon.
Okay.
And if they're the same, then, hey presto, we've got ourselves a Theia Earth planet meld, which is pretty cool as well.
Wow.
Yeah, so there we have it. A little bit of Theia has been discovered to be left on and in Earth, just in time for another little Theia's time on Earth.
And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook. We're Lost in Science on 3CR, or on Twitter where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now, where at the same time every week, Claire, Stu and Chris get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.